Hello everyone, in the previous video we did some oscillations with springs in parallel. This time we'll do springs in series and we're going to measure the velocities. Here's what I'm going to do. As you can see in the image, I'm pulling the weight downwards such that the bottom of the spring is aligned with the bottom of the wooden stick next to it. This is going to be the reference line to make sure that the spring is always released from the same position. The camera will also remain in the same position the entire time. I will now let go of the weight and let the system oscillate. All right, so now to measure the velocities, I'm once again going to use the tracker software. I will show you once how the software does track the spring and how it produces the velocity graph. So this is the velocity graph for the one spring oscillations. Once again, in the left lower corner, you can see the maximum velocity colored in yellow. It's 217.9 meters per second. Of course, these numbers are not realistic because it's based on the coordinate system of the software, but relatively it's correct. Here we have the same mass oscillating with two springs in series. And here's the velocity graph. The maximum velocity is 157 meters per second. Here's the same mass oscillating with three springs in series. And here's the velocity graph. The maximum velocity is 128.5 meters per second. And finally, we have the weight oscillating with four springs in series. And the velocity graph. The maximum velocity is 111.6 meters per second. Here is an overview of the velocities, the ratios, and the comparisons with the theoretical predictions. As you can see, the results are nearly perfect, indicating crystal clear that the velocities follow a square root relationship instead of a linear relationship. In other words, this means that you need four springs in series to go twice as slow. Regarding kinetic energy, when velocity is halved, the energy becomes 4 times smaller, not 2 times smaller. All right, thanks for watching and see you in the next video.